It's a really good demonstration. Again, I can't emphasize this enough though. Make sure that you pay attention to which side of the capacitor needs to be oriented toward the negatives of the battery and which toward the positives. Otherwise, you will hurt your capacitor and it will not recover nicely, or ever really. Okay. So now I actually have the students do a lab with capacitors. Now let me just go ahead and stop right here and tell you, if you have Vernier software, Logger Pro, Lab Pros or whatever, you don't need a high capacitance or a high resistance. In fact, I would use like 1 microfarad capacitor and maybe a 100,000 ohm resistor and have the students take data over the course of a second with like 1/20th of a second or maybe 1/10 of a second time divisions. But what I'm about to show you is for teachers who really don't have that. So if you don't have access to fancy schmancy software or whatever, why don't you go ahead and take the supercapacitors, give 2 to each lab group, obtain some 100 ohm resistors, and let me just tell you right now, the charging time is about the same as the resistance times the capacitance. So when I see 1 times 100 resistance times capacitance, that's 100 seconds. So we want to take data for maybe twice that long, maybe 200 seconds. So if you wind up using, let's say, 80 ohms, then you might only take data for 160 or 150 seconds or whatever. That's already, what, 2.5 minutes? Okay, get a voltmeter. You see me use the voltmeter from Harbor Freight Tools. Again, $10 on a non-sale day, $6 maybe on a sale day. Very worth it. And enough batteries to make 2 to 3 volts, but no more, so that's 2. It's gonna be 2 batteries, 2 AA's or whatever. A switch and some connecting wires. Okay, you don't have to use 1 farad capacitors, but if you use less capacitance, you need to increase the resistance so that R times C, again, is about 100 if you're doing it my way. If you're doing it the Vernier way, it can be less, but just play around with it. The other thing I would tell you is that your resistance needs to stay under 100,000 ohms because the voltmeters themselves have a true resistance that's about 1,000,000 ohms. So if you're attaching resistances of greater than 100,000, you're going to have some secondary effects that you weren't expecting from the voltmeter having some resistance. Here's a circuit. Basically, we've got the only things that are in series are the switch and the battery, and then parallel resistor, capacitor, and voltmeter. It's pretty simple, all right? So we're going to close the switch and we're going to let the capacitor fill until the voltmeter reaches a constant value or something like that, right? And then we're going to open the switch and we're going to start the stopwatch at the same time. Once the switch is opened, we're going to record the voltmeter's reading every 10 seconds for a decent chunk of time. This lab takes a while. It's going to take you an entire period, if not maybe more than 1 period. And by period, I mean 45 minutes. So if you're on a 90-minute block, this is going to take a whole block for you. Okay, now I'm going to do 5 total experiments with that procedure. 1 capacitor, 1 resistor. 1 capacitor, 2 series resistors. 1 capacitor, 2 parallel resistors. So this first one is our control. 1 capacitor, 1, that's our control, and then series is more and parallel is less resistance. How does resistance change the charging time? Now we're going to keep with the 1 resistor but do 2 series and 2 parallel capacitors. What do series capacitors act like? More or less capacitance? What about parallel? That's what we're going to do. Okay, so before I show you the data, I want to actually show you the lab. So let's have a look at this lab.